Hey there, my viewers. So welcome back to my channel. So in this video, I'm going to go over a React gotcha that most people don't know about. So stick around and let's see what it is. All right, so to demo this gotcha that React has, and honestly, it's not that big of an issue. I see it being an issue if you have a relatively large project and you're using this pattern a lot. But otherwise, it's a very small minor issue, but it's a really interesting problem, which it's not fixed in the current major version, or it's not really a bug per se, but it's definitely not optimal. So to explain this issue, I'm going to need React. So what I'm going to do is I'm going to use Vite. So if anyone that doesn't know what Vite is like Create React App. It's a much more efficient Create React App, and it's the new almost, I feel like it should be the new standard for setting up all different types of applications. So if you're interested in it, you can go to vite.js.dev and you can set up all these React applications from scratch if you want to start. Like if you want to do Svelte, you can do Svelte. If you want to do Preact, want to do Vue, Vanilla.js, you can do all of that. So I'm going to do one for React. So I'm just going to copy this, and the template that I'm going to use is React TypeScript. Okay, so I'm going to go here and I am going to rename this. Did that wrong, so let me do that. So create React app, and I'm going to name this React gotcha over here, and this is a React TS template, and then I have this extra C over here, so let me remove that. Okay, so notice how fast everything is. So I made a React gotcha over here, and let me jump in this folder. Okay, so now we're in this folder, and now we just need to install our dependencies. So we just have to do a yarn, and now yarn will install our dependencies, and all we have to do is yarn dev, and then we have a fully functional React app on port 3000. So let me pull this up on the side and have our code over here as well. So this one is specific to, let me try to explain the problem. This one is specific to React's re-rendering life cycle. So what React is really good at is you have all these state updates. So you would have one over here, and you have another one, and another one. And when you update state, it batches them. So for example, let's set this to count 1 and count 2, and I can delete this. And instead I will make a const handle click, and over here I will just increment set count 1, set count 2. I'm going to set count 1, get the previous value, and then increment it by 1. And I'll do the same thing with set count 2. Over here, get the previous value and increment it by 1. And I'm going to take my handle click and just put it in over here. Okay, that should be enough for this to work. Also, I need to change this. Actually, I don't need this right now because I will just use, actually, let me leave this in. It's not really important, this part. What I want you to pay attention to is if we go to our console log and we actually put a console log over here, every time we see a log, it signals to us that React is re-rendering this component. So what I'm going to do is count 1 and a count 2 over here. So count 1 and count 2, and I'm just simply console logging it. So here we have one log, so that means it's re-rendered once. Now if we click this button again, we get one unified log, and it shows that both of the states have been incremented. It doesn't work like this where React updates this component, this state, and then re-renders the entire component, and then sets this state and re-renders the entire component. React is pretty smart when it comes to that. And that's great. That's exactly what you need in 99% of the use cases. If you really wanted to wait for the HTML to re-render, you would put some other code over there that's specifically for that case. Otherwise, you should be batching up all your state updates. Now where it gets weird is when you reach the land of promises. So for example, what we're going to do is just we're going to say promise dot resolve and then dot then over here, and we're going to put our state updates inside our promise. And this doesn't make a difference actually, so I'm not going to change it. I was going to put an async over there, but it doesn't really matter. So now let's refresh our page so we have like a fresh setup. So now let's click our button count 1 over here, and you notice now as compared to the previous time where we were getting 1 console log, but right now what's happening is that React is going to set count over here, and then it re-renders the entire component and then sets the next count and then re-renders the entire component, which is why you see count 1 is 1, which gets console logged over here. And then count 2 finally catches up and says, oh yeah, count 2 is also 1, and then re-renders the entire component. So you can see where this can be a potential issue. If you have a really big application and you have state living in different parts of the application, let's say you have custom hooks that also have state, and it almost has, if you don't code it correctly, your state is not correctly batched. So that could cause some memory leaks, because then you're updating stuff that's not really mounted on your component. So you can do something. The more counts you have over here, the more dangerous it gets. So let's say 4, 5, 6, 7 over here, and then we say 7, 6, 5, 5, 4, 3. Okay, so now let me just copy all of these as well. So 2, 3, 4, 5, 6, 7, and now I can just update this. So prev over here, and I just need to set this. So 2, 3, 4, 5, 6, and 7. So now you're doing 7 updates to your state. So now let's see what happens. We click count and we get 1, 2, 3, 4, 5, 6, 7. So you can see how this gets particularly dangerous. So I'm gonna pull up an example over here and show you how you can trigger a memory leak if you're not careful. Okay, so welcome back, guys. So what I did was I clamped this up and I changed this button now to say show list. So when I click this button show list, I enable this component and it officially gets mounted. So now what happens inside this component is that I get this handle close function and I start fetching my data. So I use a use effect on the onMount state. So over here, when there's an empty array, that means this is going to get run only once when the component is mounted. And I make a fetch. So I set loading is true, I make a fetch, and then I make my response.json, and then I set my data, and then finally I call handle close, which just triggers the same function over here that closes the list from the outside, and I set loading to false. Now, granted, this is a very bad example. This is not really relevant, but if you see here, this is something that really would trick you up on what you would see, because both of these are happening in the same block of code. So you would think that both of these are getting batched, right? This function over here that's causing set show list to false, and this state call over here, you would expect those things to get batched. But because it is in an asynchronous function, which is the main reason why it doesn't get batched. So what happens is React lives on the main thread. And what happens with asynchronous programming is whatever code you write in an asynchronous fashion gets moved off to the microtask queue. So the microtask queue is its own queue and has a lower priority than the main thread. So that's doing a bunch of work. So the microtask queue shoots off handle close to the main thread. The main thread's like, oh, I need to do this work. So React does the whole update. And once it's done, then the main thread goes back to the microtask queue and says, what's the next task? And in this case, the next task is set loading. And then now set loading gets updated within its own component and it updates it internally. But in actuality, it's unmounted. So now what happens when we click show list over here, it shows over here can perform a React state update on an unmounted component. This is a no op, but it indicates that there's a memory leak in your application. To fix it all, cancel all subscriptions. Now, it might not be super helpful what's going on, to be honest, because I've been seeing a bunch of these in my code base and kind of don't understand it, because even though this is a no-op operation, or no operation, it still should signal to you that there's some very janky code in the code base. So definitely go take a look. So essentially, one tip that I want to give out in this video is that whenever you're doing state updates inside an asynchronous function that is getting shifted off to the microtask queue, and a hint that it's getting shifted off to the microtask queue is whenever you're doing updates inside promises. So in this case, fetch uses a promise, so that's why this is happening. So again, refresh this, hit show list over here, and we get a memory leak, essentially, showing that the component is trying to update, but it's not. So one thing I do want to point out is that React is trying to fix this, is trying to batch even the state updates inside promises. So this is expected to be fixed in the newer version of React, but in the most major version of React, it's currently not fixed. So you definitely got to keep an eye out of this and find your way around it. So I hope everyone found this video helpful. Let me know in the comments whether you knew about this or you didn't, whether it's helpful or not. I'm really interested to know what everyone thinks. But in the meanwhile, I will see you guys in the next video. Peace.